Hi students, this is Mr. Yao. Today we are going to continue to learn more about row reduction. In this lesson, we are going to use row reductions to solve a system of equations. But first, let's review what we have learned last time. In order to actually perform these operations given, we are going to need to transform the equations into a matrix. So we're going to need our augmented matrix. So the coefficients 1, 2, and then the answer is -5. Then we have -4, 1, and the answer is 3. Make sure you draw the line so you are separating them, the coefficient matrix and the answer matrix, because after all, this is an augmented matrix, which means it consists of two different matrices. Then we can label them R1 and R2. Something we have emphasized on last time is this row that's being added on the end, that is the row that we are changing. So in this case, we are changing our R2. That means I can keep my R1. So I'm going to write down my R1. 1, 2, -5. I am multiplying my first row by a -1/2. So if you want to write down the numbers that you may use, you can choose to do them. -1/2 times 1 is -1/2. -1/2 times the 2 is -1. -1/2 times the -5 is 5/2. But remember, these are not going to be our new first row numbers. We simply just need them to add onto our second row. Now we just need to do -1/2 plus -4 is -9/2. -1 plus the 1 is a 0. And 5/2 plus a 3 is 11/2. That is question A. Question B. Same thing. Let's start with our augmented matrix. 3, there's no y, so basically plus 0y. That's why we need a 0. And then 2. 5, -3, 6. First row and second row. We are going to, same thing, decide which row we are changing. The R1 is on the end. That means we are changing R1, so R2 will stay the same. Now let's actually perform the change. The first row is, the second row is being multiplied by -5. So we got -25, 15, and -30. These numbers are being added to the first row. -25 plus 3 is a -22, 15 plus 0 is a 15, and -30 plus 2 is a -28. Something that I want to emphasize on again, when you try to generate this augmented matrix, that's your column of x, that's your column of y, and that's your column of just numbers. So make sure your x and y's are on the left side together before you actually start generating the matrix. Now it's time to get to today's lesson. In this lesson, we are going to use row operations to solve 2x2 systems. Our goal is to make the coefficient matrix into an identity matrix 1, 0, 0, 1. Coefficient would be, our augmented matrix. This portion is a coefficient matrix. The resultant augmented matrix will look like, that's our coefficient matrix on the left, 1, 0, 0, 1. On the right are just two numbers, and these are the answers for our system. This format is called reduced row echelon form. As you can see, it's reduced down to just 1, 0. And since we're performing row operation, that's why it's row. So reduced row echelon form. Well, it's just a name after a mathematician. That's why that's the name. And in short, we typically call it rref. Since each row in the augmented matrix represents an equation, we can now look at these two rows and think about them in terms of equations. That's x, that's y, that's just a number. So basically that means I have 1x plus 0y equals a, and 0x plus 1y equals b. The zeros are gone, so basically we just have x equals a and y equals b. And that is why we're saying this column, the rightmost column, is going to be our answer. That is the solution. A general process to go is column by column. That's my suggestion. There are many different ways to solve this, but this would be the clearest way to solve it. So first you get a 1, and then try to use that 1 to get a 0 here. Then try to make this into a 1 and go to get the other 0. That's kind of a general process. Now let's look at how that works in an example. I'm going to require you to actually write down the notation to keep track of what we're doing in every single step. Because when things get bigger, when we work with bigger matrices, things may get more complicated, and it's quite hard to track or try to figure out what kind of mistakes you made in the middle. So let's have a look. We begin by writing down the augmented matrices. 1, -2, 2, 3, -5, 9. I'll write it for example 2 as well. -2, 1, -3, then 1, -4, -2. Our goal is, I'm going to write it on the top to get the coefficients to 1, 0, 0, 1, and then we may have a b right here. So let's start with the top left number. We already have a 1, perfect. Then I don't need to do anything. Next, I would be trying to change this 3 into a 0. To remind you, the 3 things we have learned to do row swap, we have learned to do times row, we have also learned to do times row add. When we times row, we cannot multiply a row by a 0 because that would just give us 0x plus 0y equals 0, which doesn't do anything to the whole problem. So we can't do that. That means in order to get 3 to a 0, we would either have to swap or times row add. We can't swap here, there's no 0, so we would have to do times row add. In order for a number to add to a 3 to become a 0, what I need is a -3. So I need to make that 1 into a -3 so I can add a -3 to 3 to get a 0. That means what I need to do is multiply the first row by a -3. So we have -3r1, then add that to my second row. In that case, that means I'm changing my second row. First row stays the same. So 1, -2, 2 stay the same. But my second row is now changed. These numbers multiplied by 3 will be -3, 6, and a -6. I'm adding those numbers to my second row. -3 plus 3 is a 0. 6 plus -5 is a 1. -6 plus 9 is a 3. Now I'm going to check against the goal again. I got my 1, I got my 0. I also get a bonus. I get a 1 here as well. So now the only number I still need to change would be this -2. I'm going to copy down everything else. So I'm not changing my second row. And the first row is the one I'm trying to change. And now you can see I am trying to get that -2 to a 0 again. Whenever you try to get a 0, times row add is the one to go. Get 0. That's the one we are going to go for. Because we can always make the other row into the opposite number, then add on to this -2 to get a 0. So let's do that. We're going to multiply the second row by a 2, because that's going to change this one into a 2, and add on to the first row. 2 plus -2 is going to give us a 0. And as you may notice, 0 times 2 is still a 0, then add on to a 1, that still remains a 1. That is the whole reason why we try to get this 0 right after the 1, because then we don't need to worry about it. As for the end, the second row, 3 times 2 is a 6. 6 plus a 2 is an 8. And that is our final answer, which we'll put in ordered pair, 8, 3. That is example 1. Let's do the same thing for example 2. For example 2, there are 2 different ways to get the 1. Because first we are going to try to get that into a 1. You can either change that -2 by multiplying it by a -1/2 to get a 1, or you may have noticed we have a 1 right here. With the 3 things we have learned that we can do with rows, here we can actually simply do a row swap. R1 swap with R2. Then that may change my second row to my first row, 1, -4, -2, or -2, and my second row will be -2, 1, -3. So again, if you want to multiply the first row by a -1/2 to get this -2 to a 1, that is totally doable. You can totally go that route. And there are just several different ways to do these questions. I changed them into a 1. Now I just need to go for this one. I now need to that -2 to become a 0. So I'm going to keep my first row, that's for sure, 1, -4, -2. And I am going to change my second row. In order to get that second row, -2 to a 0, I may need to multiply the first row by the opposite number. So multiply by a 2, and then add onto that second row. So that 1 times 2 is a 2, plus -2 is a 0. -4 times a 2 is a -8, plus a 1 is a -7. And then -2 times 2 is a -4, plus -3 is a -7. Next, Now I already have my 1 and 0. The next number I would change is to get a 1 right there. You may want to, some of you may see, oh, I can multiply the -4 by a -2, and then I can add on to the -7 to get a 1. However, if you multiply that by a -2, you may also need to do it for the 1. So that times the -2 becomes a -2. Then when you add it on to a 0, you got a -2 right here. That means everything we did to get that 0 is wasted. So that's why sometimes we may not want to do that. Whenever we get a situation like this, we already have a 0 and we just need a 1 there, we are going to use times row to get a 1. We are going to multiply the second row by its reciprocal, because the reciprocal are what we need to multiply to get a 1. So we're going to multiply the whole second row by -1/7. My first row wouldn't change, 1, -4, -2 stay there. But my second row, 0 times whatever is a 0, -7 times -1/7 is a 1, -7 times -1/7 is a 1. So even though this number is not -7, we may still multiply by a -1/7 so that we can get this 1. Lastly, we just need to get this -4 to a 0. So in order to do that, times row add. We're going to multiply the second row by a 4. So second row by a 4, then add it to the first row. That means my second row is not changing, but I'm multiplying them by 4 to add to the first row. So this one stays there. 1 times 4 is a 4, plus a -4 is a 0. 1 times 4 is a 4, added to a -2 is a +2. So my final answer, 2, 1. That is example 2. Hopefully you kind of are getting the process. So moving on, let's keep going. Example 3. Example 3, right here. First, for example 3 and 4, before you even start writing the matrices, you might notice my x and y's are not on the same side. So you got to move them to the same side first by adding 2y for this example 3. Then we have 3, 2, 4, and then we have 1, 2, -4. For this, we're gonna add both sides by a 4y. So my first row becomes 3, -6, 9. My second row becomes -2, 4, and a -6. I'm gonna write our goal on the top again. We are trying to get 1, 0, 0, 1. A, B. So now let's start performing our operations. So first, we see a 1 here. Again, you can choose to multiply the first row by 1/3 to get a 1. That is totally fine. But I prefer to just, do swap. So first, I am going to swap the first row and the second row. That's going to get me 1, 2, -4 becoming my first row, and 3, 2, 4 becoming my new second row. Next, I am going to try to get this 3 into a 0. In order to do that, I need times row add. So I need to multiply by the opposite number, so -3 times the first row, then add on to the second row. That means my first row is not changing, but my second row is. -3 times 3 is, no, -3 times a 1 is a -3 plus 3 is a 0. 2 times -3 is a -6 plus a 2 is a -4. -4 times -3 is a +12 plus a 4 is a 16. Now it's kind of the similar situation. I may want to try to get this into a 1, so I just need to multiply by the reciprocal. -1/4 are 2. First row stay the same, and second row just multiply everything by -1/4. That's a 1. 16 times -1/4 is going to be a -4. So next, I am going to try to get that 0 that I need. So now I'm going to do times row add. Multiply the second row by a -2, the opposite number. So multiply that by a second row, then add onto the first row. That means my second row is not changing. My first row is. Well, the first position doesn't change, but the second position, 1 times -2 is a -2, plus 2 is a 0. Then for the last column, -4 times a -2 is a +8, plus a -4 is a +4. So my final answer, 4, -4. That's example 3. Example 4. This time you may notice I do not have any 1s I can get. Well, then we just simply choose not to do swap. We can just, do the reciprocal to get a 1. Now, in order to get that into a 1, I'm going to multiply the first row by 1/3, the reciprocal. That's going to change the whole first row. 1, -6 times 1/3 is a -2. 9 times 1/3 is a 3. Second row stays the same. Next, I am going to try to get that into a 0. So, times row add. Times the first row by a 2, and add onto that second row. That means my first row stays the same. As for my second row, 1 times 2 is a 2, plus -2 is a 0. -2 times a 2 is a -4, plus a 4 is a 0. 3 times 2 is a 6, plus a -6 is also a 0. Oh, not only did we get this first position being a 0, we actually got everything to be a 0. So if you come to think about it, there is no way we can make that 0 into a 1 without changing the other numbers. But I want the 0 to stay, so that means there's kind of no way to change that second number to a 1. Also, because this whole equation is now basically 0x plus 0y equals 0. So no matter what x and y are, we will always have that equation. 0 times anything is always going to equal to 0. So in this case, we can't have any restriction from that second row. For this situation, the answer is not NA. The answer is actually infinitely many solutions. Because x and y's would have many answers that would satisfy the first row of requirements. So that is a special case, example 4. Moving on, example 5 and 6. Let's start by writing down the matrix first. So for this one is a special again. We do not have a y, however, the number is on the left side. So we do need to add the 4 to the right side first. We can write down the matrix 2, 0, 4. -3, -6, 14. That is example 5. Example 6, the matrix, first row is easy, 6, -4, -3. However, the second row, I need that -3x to be that 3x to be on the left side. So subtract 3x on both sides. The second row will be -3, 2, and a -2. Let's write the goal on the top again for what we are trying to get, 1, 0, 0, 1, A, B. Let's see. First, well, example 5, we do not have any 1s we can just swap into. So I am going to multiply by the reciprocal to get the 1. So first row is multiplying by the reciprocal. We got 1, 0, 2. And then we have -3, -6, and 14. These do not change. And lucky enough, we actually have quite a few things. We have this one, and we have that 0. Perfect. Now we are trying to get this -3 into a 0. So let's do that. Times row add, we're going to times the other row by the opposite number. So 3r1 plus that r2. That means my first row, 1, 0, 2, not changing, but my second row is going to change. Because 3 times 1 is 3, plus -3 is a 0. 0 times 3 is a 0, plus -6 stays a -6. And then 2 times 3 is a 6, plus the 14 is a 20. Next, I am going to try to get this number into a 1. And in this case, as you may notice, there's kind of nothing we can add to because, the other row is, as of right now, it's a 0. There's nothing we can do. So we can only times by its reciprocal, which is -1/6. So times that second row by -1/6. That means we have a 1, a 0, a 2 that do not change, and a 0 right here. This is going to become a 1, and 20 times -1/6 is -20/6, which simplifies to be -10/3. So final answer, 2, -10/3. That is example 5. Lastly, example 6. First, I do not have any zeros, any 1s, so I am going to need to multiply by the reciprocal to get a 1 right there. So times the first row by a 1/6. We may get 1. -4 times 1/6 simplifies to be -2/3. The -3 times 1/6 is -1/2. Second row, we have -3. 2, and -2. Now it's time to get this into a 0. So time to do times row add. So multiply the first row by the opposite number, which is 3. So 3r1 plus r2. That means my first row stays. 1, -2/3, and -1/2. My second row, everything is going to be added from the number we got in the first row. 1 times 3 is a 3, plus -3 is a 0. -2/3 times a 3 is a -2, plus a 2 is a 0. -1/2 times 3 is -3/2, plus a -2 is going to be a -7/2. Oh, now that second row is kind of interesting. Same situation, we can't ever change this into a 1. And to think about the equation, we have 0x plus 0y equals -7/2, which actually would never work, because the left side is going to be a 0 no matter what. The right side is a -7/2. That will never be equal on the left side and the right side. So in this case, since that does not work, the answer would be no solution. So this is kind of the other special situation. If you got a whole row of zeros, the answer will be infinitely many solutions. If you got a whole row of 0, 0, then whatever number, that would never work, so that would be no solution. That is example 6, and that concludes this whole lesson of using row operations to solve system of equations. Thank you.